if you don't escalate some of the things fast, they will never get solved. It is the logic that needs to be applied in each of those problems, which is a little harder, which is where you need your brains. Areas we have deep expertise of about 2 decades is on the engineering side. Helping companies set up engineering centers. A realization that if your data, your apps, your everything is in cloud, that is one, a lot more stable, it is more accessible, and it is resilient to any of these kind of shocks and traumas that happen. One of the best places to invest money is on technology because it improves productivity.
People are saying that, hey, product managers are saying that, hey, we don't need engineers anymore, you can just get code written. Engineers are saying we don't need product managers anymore, you can get PRDs written.
What we fundamentally believe is Gen AI is a truly disruptive technology that maybe at least I have not seen in my lifetime. I mean, to put it very simply, any type of content, whatever content you want to generate, can be done by Gen AI. So software engineering, the way it was done, will definitely dramatically change.
Hey, welcome to yet another episode of Scalar Pod, and today we have a very interesting guest with us. Hi, Siddhant.
Hi, Arnav.
So Siddhant is president at Zinnov, and I'm very curious about a lot of questions because I have had a lot of guests so far who have been, CTOs at product engineering companies. That's something like I believe a lot of the audience gets, like, okay, this is an app, this is the company that builds it. What kind of role does tech have to play in a management consulting firm? I am super curious. I have a lot of questions, but I'll really start off with your journey so far, which has taken you here. Okay, so let's start from there.
Okay, and that's a pretty open-ended question. So, but yeah, it's a good place to start.
Yeah.
So I think if you look at it, I would say there are multiple things that I've done, both in terms of the companies that I've been and also the things that I've done within Zinnov over the last 14-15 years. So if you look at where it started, it all started with very deep passion about mechanical engineering.
Okay.
It could have been for multiple reasons, right? And I loved cars from a long time, and planes I used to really be interested in. And interestingly, the community I came from, so we were in the ISRO quarters, dad was in ISRO. So everybody around is, thinking about the same thing almost. Yeah. So there was almost no other option, but at least I was interested in it. So, and it so happened that I did become a mechanical engineer and almost was one of the few folks who consciously stayed out of the interview process of Infosys and TCS, and I don't know. I mean, at least I would like to say I was consciously stayed out and not from the fear of their aptitude exams. But it kind of worked out well because the first job I got was in Toyota Kirloskar Motor in Biddi. It was Toyota's first manufacturing plant in India, right? And it still is the only one. My role there was that of a quality engineer. Out of all my years of experience, I think that 1 year was really amazing in terms of understanding how things actually work. And there's this thing about the Japanese way, right? So at least at that point in time, anybody above senior manager or at manager level, above manager, was a Japanese person. And we had only heard stories that Japanese work for 24 hours and they work like non-stop, they don't go home. But you would actually see that in practice. So I remember one of the initial few days, so I was in charge of all the engines that's going into. At that time, we used to make Qualis and Corolla. The engines that used to go were responsibility in the sense that things should be fine, it should be in shape, nothing should happen. So in a manufacturing plant, in say an automotive manufacturing plant, the worst thing that can happen is that the line that is moving, so it's typically a long line where it starts from the press shop, goes to weld shop, paint shop, then there is assembly. There's a long process and it keeps moving all the time, right? And every X minutes, depends on the manufacturing, line produces one complete car. So if there is a stop for even a few seconds, that affects your production, and production affects your company's output. And that is just revenue that is being lost, right?
And this Henry Ford.
Yeah, exactly. Like that, right? The difference in Toyota versus some of the other companies is the empowerment for line stop. Like if you go to, and I've been in Tata Motors also, right? Any person on the line, it could be a person who has just joined Toyota and is fixing a bolt, that person can do a line stop. So there is a line that's going, like in the trains you see, there is a, like you see, you have one chain, right? In Toyota plants, there is a single rope kind of line, right? And you tug at it and the line will stop. No questions asked. And you're encouraged to do a line stop. And I was like, and this is something that really shook me. Like, how do you empower somebody at that level to do a line stop? And as soon as there's a line stop, if you're in the office, there is a light that glows, and all the managers are like running and seeing what has happened. The line stop could have happened only because of two bolts are not there for that person to be putting there, for something as trivial as that. So the way one of the Japanese folks explained to me is, if you don't escalate some of the things fast, they will never get solved. And I mean, I've seen further when I went to some other companies, you would see like hundreds of cars just standing there because they had missed 2-3 parts, and for months they used to stand there.
Right? They missed the final inspection.
But somewhere it is there, and जब वो part आएगा तब लगा देंगे उसको. But that never almost ever happened in the Toyota plant in that time I was there, right? So sometimes when you escalate, everybody gets activated and they ensure that things are in shape, right? So that was one amazing learning that I had. Outside of that, it is just the work ethic, right? So something that stuck to me is the fact that at any point in time, your work and the demand on that line is the most important. So, for example, I remember on one of the days, like typically if you're an engineer, you work in general shift. You catch a bus, go to Birdi, come back, 9 to 6 kind of work. One day in the second shift, that's the previous night, I got a call. And again, this is again empowerment, right? So I'm just 3 months into the system, but I'm the person the folks on the line are calling because there is some problem in the engine. The engine is giving white smoke, and they had to stop the line for that, or almost stop the line for that. And he said that if this persists in the morning shift, then we will have to stop the line. And line stop is like this cannot happen, right? And if it happens, then like for next 4 days you're doing paperwork on it.
Yes.
So that was and then so I said, okay, I will come in the morning. So I took the 3:30 a.m. bus, went there, figured out what the problem is, etc. And by the time the typical general shift came, the things were sorted. Again, the same learning, right? So one learning is the teammates at the lowest level, if they are empowered, they will also solve problems for you. Yes. Second, they will also identify problems for you, right? Identifying and solving empowerment at the lowest level. I think that was a wonderful thing that I learned, and also the work ethic in terms of everybody being available at all times. So that was, like I said, I had a lot of opportunity there to learn. Not just that, but also look at, it was the first time that they were launching newer cars, right? So you needed folks to even test cars. So they had built a high-speed test track just then. So there were people who were trained to only do that. And they had got, so Toyota has multiple levels of drivers, right? So Toyota also has an F1 team. Yeah. Right. They have drivers certified up to F1 driving standards. So there's F1, and then you have 2-3 levels below that, and then there are trainers, etc. Right. So they had got 2 people who were F1 certified to train people to drive there. Oh. Right. So, and that was the first time for them, and those guys were like I don't know how to put it, right? So maybe sometimes when you reach that level of intensity in what you do, you become a little, not normal, right? So and their skill level was just amazing to watch them. And then they said that, hey, we can't have these guys here all the time because they're expensive and they are needed in multiple places. So they encouraged one of them to train a few people. Hey, can you train these guys? So there were about 15-20 nominations, and they said, okay, this guy says he knows how to drive well, so take him also. But he said, no, I don't think any of you guys are worth it. How many hours of professional driving have you done? And all the 20 of us like, wow, what is professional driving? We are all engineers out of college, or some of the other guys were like 5 years, 6 years in the system. But he said, oh God, what am I supposed to do now? He said, okay, I will do a qualification test. If you qualify, then I will do. Otherwise, I'll tell my boss, these guys are not worth it. Maybe next year you train a few. We'll give you some 1-year program and then you go. So then that happened, and then he chose about 4-5 of us he chose, and he said, okay, we'll give you 2 months of training on the test track and outside. They did not let us enter the test track for at least a month. And we were like, what is this guy doing? And he's teaching us how to brake, how to turn the turn handle, how to look in the rear view mirror, where to stop by turning right. I'm like, ये तो कुछ ज़्यादा हो गया ये तो bore कर रहा है But then I think when they actually went to it, you could see the reason he was doing it, right? The skill level that is needed to do some of those tests. For example, the suspension test, when you're moving from at 120 kilometers an hour, at within 1 second you're supposed to change a lane, and your body should not roll. I mean, there are different things that you check in a suspension, and the steering should be very clean so that you can do the roll test, all kinds of things. But to do that, you need some precision in driving, and that is what they were teaching, and precision in braking. I think it was a wonderful experience. I still remember it's one of the best things I've done in any job.
Once in a lifetime thing,
Yeah.
for sure. Yeah.
At the same time, there was always this, like I said, right? I want to design. I want to do something of automotive. Yeah, this is good. Yeah, I love cars, and I think I'm having a great time here. But can we do better? So that's why I said, okay, let's try where we can do actual design work. And at that time, and even now, I think the Tata Motors Engineering Research Center is one of the best places to do automotive design. And again, I had an engines background, so they got me so my title, interesting, was Research Engineer, Internal Combustion Engines.
Okay.
So internal combustion engine now doesn't have a market, so I'm happy. I'm happy that I'm out of there. But I think that was a great place, right? So they had so many test beds. So each test bed, you can put an engine and run it for hours and days together. That's a fun of its and thrill of its own, right? So something that now, if you want to do, you have multiple videos to see how it's done and people are talking about it. But to actually do it was again a thrill in itself. And to work on the design of some of these engines, all the things that you talk about, fluid mechanics and strength of materials, this, that, all those things we were able to do. It was a great experience at that time. I don't know why, but not satisfied. It was great. I mean, nothing much to complain on the work side. There was this interesting ad that my friend and I saw in the papers, which said that, hey, we are looking for engineers with mechanical background who know automotive. We will, help you work for some of the biggest industrial companies in the world or software companies in the world to develop software for them. And we are like, what software will they need from an automotive engineer? I didn't even write the Infosys test. And I don't want to be in Infosys also. But what do they want? The only thing interesting was the pay package. Right, and about 3 years out of college, it's an interesting thing, and we had heard good things about that. And there's some of our seniors who had gone there from, like, say, Kirloskar Oil Engines, etc. And so they said, hey, it's a nice place, why don't you try? I said, okay, ठीक है, let's go. Then I asked, aptitude test होगा क्या? I said, हाँ होगा. मैं बोला यार ये तो नहीं करना है. But yeah, somehow got through that aptitude test, got through that interview. And interestingly, they were asking engineering questions, which I didn't expect them to ask. And I'm like, okay, let's see what they really want from us. So we joined. I think it was a great experience. For 3 months, they were teaching us software coding. And then we were put on real projects and I was working for a company called Siemens PLM. It's still around. They make PLM software, which helps design all kinds of components, right? So you can design a car, you can design components like engine design. So the way design happens is like you visualize something, maybe you draw it out. But at the end of the day, you need to create a 3D model, right? Okay. So if you create a 3D model, and then on those 3D models, you have to apply certain stress, structure. I mean, you have to figure out whether it will sustain the loads. So all kinds of stress loading. And there are software for that, like ANSYS and some of the others, MATLAB for kinematics, etc. So that is what they were making those software. Okay. So on the Tata Motors ERC, I was using them, and here these guys are making them. So the challenges they had were very interesting. So for example...
So it's like designing software for physical components.
Yes.
Okay.
Yeah. So this is a software where you can create some of these components. Like, so SolidWorks was one of the works. Correct. So that is one of the things they have. And then they had a product called Delmia. That's the Dassault product, sorry. But these are products where you can create the entire manufacturing plant. You can design it. You can figure out the motion of a robot and how it's supposed to move, coordinate that with these guys. So I think that was another interesting place, right? The difference is each of these companies was very different in the way they work. Like Toyota is like on the plant. If I came back to office, my manager used to stare at me. Siddhant, DPV zero हो गया क्या? DPV is defect per vehicle. Yeah. So it's obviously never zero except in the Toyota Motomachi plant where it is almost zero. So it's like, is DPV zero? It's like, no sir. Then what are you doing here? So a helmet pehno, वापस like. So it's again great experience. You in Tata Motors, it was the experience of just looking at those amazing huge machines. We used to have the silicon graphics machine, which had the ability to process that much amount of graphic data. I'll come back to this in the context of Gen AI again. Sure. Yes. But those were like the OG machines which were able to process amazing amount of data. Graphic data, help you model it, help you section it, etc. Again, and each of those machines are extremely expensive, right? So you need somebody like a Tata or some of these big companies to own them. Now coming to software engineering, there was the lifestyle was different, if I put it that way, right? So in Toyota, we had to be available to go up at 3 a.m., 4 a.m. also. Otherwise, at least at a certain time in the morning. Software was a lot more chiller, I would say, right? So you had huge cabins, and I had this massive cabin, 2 monitors, 2 computers, and I was just almost an entry-level engineer, right? Yeah. So because I didn't know much, but I also had all these nice fancy stuff for me, and I'm like, wow, yeah, acha hai. And then you can walk in at around 10, 11, do your work. But what I noticed is the efficiency when you're doing the work. There are a lot of things to support you, like for example, you're not finding your way with many things, so your efficiency is much higher in that scenario. So that again was really, really amazing. I mean, we used to, and again what I realized is software coding is the easy part. It is the logic that needs to be applied in each of those problems, which is a little harder, which is where you need your brains and also the understanding that we had from and I could relate as to why they needed people who know automotive rather than people who know coding. And again, this is something that unfortunately I didn't have Gen AI at that time. Otherwise it would have been a lot more simpler. But again, really good stuff. But again, just as any other unsatisfied engineer, after 3-4 years of work, I said, अब क्या करें, अब तो नहीं तो कोडिंग ही करेंगे जिंदगी भर, अब क्या करना है? So okay, let's do MBA. So there's nothing non-traditional about it. Yeah. But that was the thing, right? But I think the interesting thing is, the options for B school, if you're in India, are not very high. So you have the IMs, you have at least that time ISB was something new.
Coming up, yeah.
Yeah, it was about few years and it had made a good name for itself. I said, okay, that is one option. So either you write CAT or you write GMAT, and then you have the Excels and all those, right? So we prepared a list. So like I was telling some of your friends here, I used to be in Bombay. We had a 1 BHK and 3 of us were there. The other 2 were also in the same boat. So we were all sitting and trying to prepare for CAT, prepare for the XLRA exam. Somebody's writing GMAT. So that itself was a fun experience, right? You have to slog it out and work, but come back and do your own study as well in that small place. But yeah, somehow managed to make it to ISB. And post that, again, I think this seems to be the irony of my life, right? Wherever I don't want to go, I kind of end up being there. Like I said, I don't want to do software, but I somehow ended up doing software. And in the entire time in B school in ISB, again, in ISB you can do a lot of things. I chose not to do anything on consulting. And I had this running joke that, I'm an engineer, I want to do real things, and consultants are only, telling you what you already know almost, right? So I don't really want to do consulting, right? So, and I did not go to any, so we had these case exams and we had the consulting club, not part of any of them, right? So I said, okay, we'll do some GenMan role or whatever, right? As things were to have it, again, that was not the greatest time to be coming out of B school from a job perspective. So we are just trying to figure out where whatever comes. So I did get the first job I got was in, Cognizant Business Consulting. So luckily it was on the day zero, day one, and that time the rule was you get a job, you go home, like that's it. Just because there are that not that many, so I'm like, okay, job to mil gaya, chalo ghar chalte hain. So, and again the recession at that time was still on, and post our graduation,
So
we
2010.
this is 2009. Yeah, correct. It's the same time. Yeah. So that, and then you say that, okay, I do have an offer, but the offer is getting deferred. I'm like, what is this? Is something new? What does an offer defer mean? I'm supposed to graduate in April, join in June, but that is not happening. And I said, okay, there's an ISB is not cheap, right? So there's so much loan that you are supposed to do. Now the thing is, either you defer the loan, that is also an option, or you pay from your pocket, and your pocket is typically empty as an engineer just out of like 2-3 years of experience, or you ask your dad, and that is not the ideal option. So I said, okay, we degree here, let's try to see if there's somebody else willing to accept me as a engineer with some with B school. So that's when I started looking for jobs, and that is when Zinnov happened, interestingly. So Zinnov was looking for somebody with aerospace background. I said, वो ज़्यादा नहीं पता है. I said, no, you will figure out something, you will do. So I think the joining of Zinnov also, and maybe even getting into consulting, was not something I had thought of doing. But I think after coming into Zinnov and spending some time here, looking at the work that we used to do at that time, and looking at customers actually being happy about what they're getting, and the impact of them in terms of their ability to scale and grow, that is when I kind of realized to myself that yes, consulting has like clear merits, and there are clear areas where you can add value. And also the fact that Zinnov has always been very focused on the engineering space. In fact, that is what I was even asked to come in and do. So we've always been close to the engineering community. Like, for example, helping many of the companies discover what is possible in the India engineering ecosystem. So I remember making these presentations, like multiple presentations every week, to people who are coming to explore the India possibility in India in terms of setting up their engineering center, or companies that are very small, have 100 people, but large companies like Daimler and Mercedes were also like less than 500 people about 10-12 years back, right? So when their management used to come, so we used to make this presentation, hey, India is great, India has amazing talent, and then we used to have slides on NAL, ISRO, see, we have gone to the moon, and we can actually do very, very cool engineering, and we've gone through the grind in terms of people being extremely skeptic about what they can do in India, to now being at a place where even if you tell them not to come, they are still coming.
I mean, opening an engineering office in India is quite a no-brainer for a lot of globally expanding companies.
Yeah.
Just think like, okay, what's the next step? We need to expand the engineering team. Okay, let's open an office in India. That's kind of like a default, right?
Yeah, I think that has become because if you look at it, right, what India has been able to do with the engineers that are coming out, and there has always been a good engineering ethos, especially in Bangalore. So, I can just explain from my own personal background, right? So if you think about, if you just look at the large PSUs in Bangalore, BHEL, HAL, NAL, then your slightly higher end scientific works like ISRO, NAL, ARD, all kinds of centers have been established in and around Bangalore, right? And then there is this
Indiranagar, like that whole area.
Exactly, and that's where I used to stay, right? So in the ISRO quarters, and suddenly the ecosystem is all about engineering, right? And then when you grow up, and luckily when that generation was coming up, then all these IT companies came in, and the IT companies were able to absorb this engineering talent, and then IT was one of the first boost, and then you had a lot of core engineering work. Like I remember when I went into Toyota, Tata Motors, the core engineering work had to be sought out. We had to really find the company that does engineering work. Now it is, everybody wants to do like core engineering work in India. It could be on software, embedded, If you look at semicon, the number of companies looking at India, Bangalore, Hyderabad, Pune, it's just off the charts right now, right? So I think that's one of the satisfying things about being in Zinnov, to see that entire journey where you're trying to convince people to come here, and now you're like, okay, you want to come, okay, we'll help you. I don't think we ever, yes, we do, like you have the same slides, but nobody needs the hard push or like solid convincing or to show the Chandrayaan for them to believe that we can do it here, right? So I think that's been a interesting journey. I still remember uh, one of these global stakeholders, when I told them, hey, you see, India is almost the second country to have gone to the moon, and there was a sniggering remark that they made, saying that yes, you can go to the moon because you don't need to take a road to the moon. So that was just a comment maybe from like the travel from airport to their office. But yeah, I mean, we've seen that. But then, I mean, obviously the infrastructure has improved, but yeah, it can do better. But there has been a very interesting, and I would say a very wonderful change that has happened in the mindset of how globally people perceive the engineering talent and the ability of the engineering talent to deliver great work out of India.
Right, yeah, makes sense. Coming to again, like I said, at a management consulting firm, and like you said before you had joined, like your thoughts about they just tell people what to do, they know what to do, and I'm sure like a lot of people who are on the builder side of the aisle, who are engineers, I think a lot of people think the same about management consulting, McKinsey comes and gives you advice which you already knew. It's like there are even memes around that. But yeah, I mean, if I had to actually ask that question, when you're working with technology companies, what kind of things that would be Zinnov would be doing?
I think the way I would, if you look at management consulting itself, right, there are about 2-3 types of things that most companies do, and we would also fall in that bucket. And each one needs a different type of expertise, and there's a different type of value. The first one is what I call deriving insights kind of work. So when I say deriving insights, it is, say for example, you want to tomorrow go and set up a chain of retail stores which are very niche, or maybe selling only organic food or organic based everything, right? You have the money, you have a great product, but you want to open a retail chain. Now the question that you will ask yourself is how many, where, which is the best demographic to target, how do I do it? So those are the classic management consulting insight related problems, where somebody is looking at market, looking at a huge amount of data, crystallizing it based on your product and telling you, hey Arnav, so you have this product is best for this demography, this region within Bangalore. So your first store should be in Indiranagar, second in Whitefield, and then when you go city to city, this is how it should be. Each store will have a cost implication of so and so, revenue of so and so. This is going to be a burn rate, the entire business plan, right? So this is your classic, I would say, insight driven, almost outside in, right? Where you're only analyzing market data. Maybe you're doing surveys, you're doing primary interviews, but that is one part. The second one is where it involves more expertise, or there's a professor who calls it gray hair consulting, even if you don't really have gray hair. So what gray hair consulting means is, if, say for example, you have been doing the scalar work for 10-15 years, you intuitively know what edtech means, right? You don't need to really spend a lot of time to tell someone whether a business that you are seeing in edtech is great, good, bad, ugly, has legs, does not have legs, right? So there's an element of gray hair. Now, many of the projects that we are doing at Zinnov fall in that category. So I'll give you an example. So for example, one of the deep areas we have deep expertise of about 2 decades is on the engineering side, helping companies set up engineering centers, and also help services companies, the Accentures, Cognizants, etc. of the world, to develop their own engineering as a service, right? So which areas do you target, which companies do you target, how do you target, and also because we have been working with them for so long, we know which companies are doing, like internally how companies should be set up, like what structure is needed, what org works, what kind of leadership works, where are things that are good, bad, etc. So on the expertise side, like when we when companies come to us, we are able to tell them exactly on how do they need to get into, say, the engineering services space, like which verticals to target, what kind of leadership to hire, what would be the way you are able to get there. And again, a little bit of this is insights on market, but this market insights is actually something that almost everybody can have. And in the age of Gen AI, you can have it by just a simple Bing chat or a Copilot chat, right? So I think what we are increasingly seeing is this insight related component is getting easier, faster, more commoditized. It is the expertise. So if you have expertise in certain area, it will get commoditized a little bit, but it is still going to have legs to sustain for some time. So in terms of really understanding how to, say, set up a GCC, so we have teams that have been doing it for decades now. In terms of helping companies grow in a certain area, that's something that we intuitively understand. Or even, for example, we work with a lot of investors, the private equity companies, VCs, who are trying to invest in these services companies. So for us, it does not take very long to just look at what they're doing and give a first sense of, hey, this is great, or this is, oh no, this is just one of the other 100 of these guys, and that is the advice that they're looking at, right? So first, because many of the projects that come from investors are very short burst. You don't have the time that, like I explained in the first one, right? You need like 6-7 weeks only to get the data, get the insights, funnel it down. So investors are typically looking at short bursts, 2-3 weeks, and that is where your expertise or your classic gray hair becomes very important. And what we are seeing is more and more of these type of projects which are coming our way because of multiple reasons. One, like I explained, right, most companies now realize that having an engineering center in India is extremely important, and that's why there are dozens of them looking and exploring this possibility, and they need help, the actual core help to help set it up, right? That expertise is what they need. Similarly, if you look at the overall IT services space, there is your classic IT, apps, etc. There is BPO, and then there is engineering services. Out of these three buckets, the only place which is growing top down, like IT is growing about 2%, 3%, engineering is growing at about 10%. So the only space that is growing fast is engineering, and that is why all the service providers are also interested here. Companies that don't have engineering services are also interested in this space. So yeah, I think this is where we seem to have found a sweet spot of the ability to do the horizontal insights very fast, and then there is expertise in certain areas which allows us to carry this. There is also a third part of engineering, in consulting, which we don't do too much, which is the ops related consulting. So for example, if there's a telecom company that needs to roll out 5G, right? So there's a huge amount of program, there's a big program for it, and there will be like 50 people in the program management office to coordinate, to ensure that the tower guy is here, that program. So that's mostly ops consulting, right? So that's a place where we don't do too much of. So Zinnov is mainly in the first and the second part, more in the second part, or the second part typically it cannot do without the first part. So that's where, to your question on this one, I think these are the three flavors you will find in most of the big fours, in the MBBs. They do all the three. Right. And depending on the project, you would be put on one of these, right? So sometimes it is interesting, sometimes it is not so interesting. That is your own personal choice, but yeah.
Fair. Would love to talk a little bit more about, because when you have a lot of experience on companies setting up engineering centers in India. I'd ask, this last couple of years have been like major shift in terms of how people think about engineering costs and budgeting for them, and at the point where the rubber meets the road, where engineers are looking for jobs and figuring out what kind of industries to go to, they also see the shift, like how the companies work. Obviously there have been layoffs, but there also have been like the way companies operate on engineering products, and a lot of things have had a bunch of dramatic shifts. Like I think There have been pendulum has swung both ways. Once because of COVID, then once back. What are the trends that look like for opening up an India Engineering Center? For which kind of companies does it make sense? And going forward, what more types of companies do you see who would be doing this?
Right. I think that's a very interesting question, and it has a few facets. So maybe I'll start from the most interesting facet, right? And I think the most interesting thing that has happened in the last 5 years is the post-COVID scenario. I don't think anybody in the world expected what would happen post-COVID. So especially in the tech world, what we saw is people were in lockdown, but just after that, there were 2 or 3 really big shifts that happened in technology and technology adoption. One, I think there was a place where people believed that technology can really solve multiple areas which they had not thought of before. It could be in terms of just speaking to each other, or even complex things like getting doctors to operate on somebody remotely. So there were a lot of possibilities that were proven in the time of COVID.
So you were forced to do it remotely, and now you realize that okay, this works.
It is also possible, right? So a lot of the status quo was challenged and in fact broken, right? And many of those things have continued. The other thing that happened is a realization that if your data, your apps, your everything is in cloud, that is one, a lot more stable. It is more accessible, and it is resilient to any of these kind of shocks and traumas that happen. And that was, I would say, a big inflection point for many of these hyperscalers to just resurge in the market. When I say hyperscalers, this is your Microsoft Azure, your Google GCP, Amazon AWS, etc. Right? So these suddenly became the standard for all enterprises. Till then, enterprises are like, hey, I'll put my own small cloud setup.
On-prem to cloud shift has happened.
Yeah. So that was a huge inflection point. I mean, there's still a lot of on-prem, but the movement that has happened in favor of just these 3 companies is phenomenal. And that has also the macroeconomics that has supported it is the amount of money that was pumped in by the Fed and some of the other companies to sustain the economy. Then the money was available, and one of the best places to invest money is on technology because it improves productivity, and that's something that you saw, right? So investment in cloud, investment in all kind of tele everything. So suddenly there is this huge demand for engineers to build better products, to engineers to build better everything. And then there was another unfortunate macroeconomic event, which was the Ukraine war 2 years back, exactly 2 years back almost. And just as the time when the world needs thousands and thousands of more engineers, the Ukraine war actually took away a huge talent pool of engineers. And I still believe the Ukraine, Romania, that geography has one really high quality engineers, and also engineers in a large
the former Soviet
large scale.
Yeah,
exactly. And that pool actually had sustained a lot of new development that was happening, especially from the European countries, because that is closer.
Just before COVID, if I remember correctly, a lot of the large this FAANG and big tech companies, many of them had started opening up development centers in Eastern Europe as well. I think Poland and Hungary and all. Yeah. I think that push has stopped a bit because that area has become a little risky now.
Correct. So I think that is, like I say, I continue to maintain it's very unfortunate because, it definitely is not creates a very significant imbalance, right? So, yes, to an extent, you could say that India, at least the India engineering side, is to an extent benefiting out of it, but it creates its own challenges, right? So like I said, if you look at the story is the world is doing a lot more digital adoption. You need a lot more engineers, mainly engineers with a lot more software skill than something else. But at the same time, you're taking away one large pool of engineers from the world. Right, and this actually challenged multiple companies in their transformation journey. And the third thing that happened, and this is maybe some sector specific, is in the automotive world. COVID almost forced every government to take a stand on the environment. And most governments across US, Europe said that we will be more stringent and we will ensure that the environment is safer for our next generation. And that the first place where each of them typically goes is on the automotive side. Okay, so you have to improve your emissions year on year, and many countries, including Germany, said that you can't have IC engines after 2030 or 2035. Right? It's almost unimaginable for Germany kind of countries to say that. US always toys with it, but again, it's very difficult. So that kind of regulatory impact, and also the fact that Tesla is doing so well, pushed almost every automotive company into the EV part of the world. And being from automotive background, I can tell you that typically the engines team within the entire R&D has almost the pole position. So they are the kings of the engineering world, right? Because they work with a pretty complex players. If you're able to crack the best engine, then the remaining things are can carry a little bit of weakness in some of the other components as well. Now suddenly you are saying that, hey, you guys are irrelevant almost, right? Fine, you are irrelevant. But who is going to make the new electric vehicle? There's nobody inside the company who knows it, right? They don't know. There's no electrical drive engineer. There is no battery engineer. The only battery engineer they have is the one that goes there with your Exide or Amron battery, right? That's the best that they do. So now suddenly there is this completely new thing that they're doing. That is one massive change. The second thing that happened is, some of the cars, again, Tesla, again, I would credit for this massive disruption is, if you look at the autonomous driving, right, and Tesla has been doing it for a while. I would maintain that Tesla is about few years ahead of any other competition, and because of that, they are able to gain market share as well, right? So they are EV and they are autonomous, and these other traditional companies are neither. Right, the best that they have in autonomous is your self-rear parking, right? And so they were completely challenged, right? So one on the regulatory side, one on this side. So they have to again deploy a lot more engineers to create new products in products where they don't know how to create, and you need massive pools of engineers. I think about 1.5 years back, BMW went on record saying that we need 60,000 new software engineers. And if you've been to Germany, you know that yes, it is one of the biggest places where, in terms of engineering education, but they don't have 60,000 software engineers. Right. And there's no way you can get 60,000 even in 5 years. So what is the option, right? The option is to look at somewhere else. And in that somewhere else, the lowest hanging or the easiest place is India. Because one, for 20 years, people have done it here. Right. Then there are so many services companies that do it very well here, right? So your TCS, Accenture, your mid-size LTTS, etc. They have gone from almost nothing to billions of dollars of business doing engineering work.
And you see that happening, like the automotive research being captured by the India market.
Yes, it has happened. So if you look at just the growth of some of the centers here, so Daimler has always been here, but now the center is so large. Now Bosch is more than, I might get the number wrong, but it's maybe in the 20,000 plus number of engineers that they have.
Yeah, they have a bunch of big offices now.
Correct. And it's not just that, right? So they also have control over some of the other offices outside of India, like the Vietnam office under the Bangalore hub per se, to look at it. And the other thing that has also happened is, if you look at some of these services companies, and they have been able to ride this wave. So if you look at, say, a company like Tata Technologies or a KPIT, which knew automotive for a long time, but it is now that there is this surge of work, and then the market is valuing them like crazy right now. So KPIT's P is about 70 right now. Most companies, normal companies, are at 25. TTL had almost insane, like 4 or 5x revenue valuations when they listed last year in the market. So all of this has definitely created a huge impact on the ecosystem in terms of demand for engineers and companies wanting to come here. So that is, I think, a big reason why almost every company that doesn't have something significant in India from an engineering perspective is looking at India. Or like, for example, the latest BMW deal that happened, and quoted that example, right? They are in partnership with one of these service providers, almost as a joint venture, to set up something in India. So either they're coming alone or they're going with a services partner or doing like a joint venture to so that they have best of both worlds almost. So it's I think one of the most interesting times for engineering services within the India ecosystem.
Got it. I have another question, which is I think you would have some insights because you have been, on the manufacturing and automotive side. You have, very hands-on experience in the past, and I'm sure you have understanding of the, larger environment there. Which is, so one thing is like obviously software and like the software that goes into say cars or other things. What the general perception is like what a lot of people say, and even if I just a layman's perspective is that India never picked up on a lot of the manufacturing sector, and if you go to anybody who is manufacturing anything at scale, like the machines that they use now that is made in India, they're just importing from a bunch of European companies, which is what makes a lot of those things. Even I recently went to this coffee plantation in Tamil Nadu, and they I think are the largest one in they export from Tamil Nadu, and like all of those things like the boiler, the thresher, the roaster, the sorter,
German
machines, yeah. And I think there's only one Indian machine there, some Mangalore-based company which makes an optical sorter.
Wow.
So, and that's because that's heavily reliant on software. So, like those old beans are coming through, and it takes a snapshot and it sees like the green ones and the red ones and all of that, and it can sort the greens and the reds out of that, right?
Right.
And it is doing it at I think some like 500 beans per second it can sort. It's doing it really fast. Obviously, like the final, like the sorting flap, there is one mechanical flap. The rest, it's all a software thing. Taking a photo, doing image recognition, finding which ones to do, right? It's able to do it very fast. And I was asking, like the owner was giving me a tour through everything. I was like, where are you getting these machines from? And he was showing them, like most of the larger machines generally have this metal plaque which says where it is from and all of that. And I was asking him, like, are there any alternatives in India? And he was saying, like, they have done a lot of transformation towards automated systems in the last 5-6 years, he was saying. And he was saying that even the automated version of the machines are again also coming from maybe some other company, but again, Europe only. And the optical sorter is the only one that was made in India. Did like India completely miss the bus on like the making these machines like which fit into some place in the assembly lines, which are part of these manufacturing supply chains? Because there also a lot of automation is happening, like in terms of control systems and all, they are advancing a lot. Some of them are even getting AI based control systems these days. Like is India part of that story in any form?
Yeah, I think that's a good question, and I think one of the good things of being in a consulting company is you get time to discuss a lot of things with people, and each one has a good opinion. So I'll tell you what I have crystallized on this particular point on what you're saying, right, on the manufacturing and India being a little late on it. And the way I think about it is in terms of evolution of any country. And that is one side. The second side is what it takes to set up something on the manufacturing side. I'll just take the manufacturing and the complexity and what is needed to set up manufacturing. So there's a lot of buzz on, hey, why is India not doing semiconductor manufacturing, for example, right? Now it's easy to say that, while if you look at, let's take a fair guess, right? So how much do you think in terms of billions of dollars it takes to set up one normal chip manufacturing facility? Just one.
Chip manufacturing. That'll probably be in tens of billions.
Correct. So it takes at least $20 billion to set up one decent setup, right?
Because I think I recently was looking at when TSMC wanted to go to from 5 nanometer to 3 nanometer, they have, I think, taken up an investment from Apple and Nvidia of the order of some $10-20 billion.
Now that is only for research. Yeah, and then the equipment
from one nanometer to another one. Correct. They already have a foundry.
Yeah. So I think there are two parts to it, right? One is the actual setup is first very expensive. Second, it needs a huge amount of resources. So when I was reading this, right, so each semiconductor factory would need so many x billions of gallons of water.
Yeah,
Or,
you need like clean distilled water,
yeah,
supply of sand,
and
and all like a lot of things.
such a high amount of electricity supply that needs to be done, and they need it, either you have it captive or somebody's providing, right? Now and this is not only for semicon. If you look at any other larger manufacturing, it needs high investment in terms of money, it needs high access to resources, and then you need a transport network, etc. So if you and when I going back to my first point on evolution, right? So if you look at the India as a country's evolution, we almost started with almost little or no infrastructure except for the railroads which were there. The roads were dilapidated. So the basic infrastructure in terms of water access, energy access, road access was always poor. So even if somebody had the money, let's assume, but you're a not so rich country, right? So you don't have the money as well. So it's almost impossible for us to have said that we should have done this 20 years back. I would say it was almost impossible. But what could you do 20 years back? You would do something which is less capex heavy, or which doesn't need so much resource, so much investment. And what is it that India had? India had and still has brain power or horsepower in terms of people, demographics, intelligent people who are able to solve all kinds of things. And that is why you saw the Infosys and the Wipros of the world and many of the companies that set up their India engineering centers early. So we were able to utilize our what was easily accessible without spending a lot of money or resource to come up to a stage where we now have, I would say, the infrastructure development in India is faster than anywhere in the world, right? So I was reading it's about 41 kilometers of roads per day, and the second fastest is somewhere in Europe, which is about 20 kilometers a day, right? So we are now at a stage where we are able to build infrastructure much faster. We are at a stage where now there is a lot of investment for India as a destination. And third, there is recognition of India's ability to do this, because we have proven that we can do this in some of the other companies with in tech companies and manufacturing companies, telecom companies, you name it, and the Indian folks are there leading some of these, right? So I would say that in my mind, I'm overall a optimist. I don't think we have missed the bus. Maybe there were things we could have done better, but I think the time is now, and now is when we have proven expertise in multiple other areas. We have better infrastructure which will allow us to give access to whoever wants to set up these larger manufacturing setups or facilities. And the third important thing which is there, and you see it everywhere, like for example, Intel set up its latest fab in US. The government almost gave it half the money to set it up, right? And that's the amount of government intervention needed for large manufacturing setups, in terms of either tax breaks or even just giving them a corpus to set it up. And then because the impact is much larger, right? So now we are seeing that kind of policy change as well. I don't think if the policy was there 20 years back, it would have helped. Nor I think that if money was there, it would have helped, or infrastructure. Everything has to come together, right? And again, I don't think we are already there. Maybe we can't yet think of this 3 nanometer chip for us right now. We have to start with something smaller, larger nanometer or something else. But we will. But I think that is the path to go. And it's only when you have large capex coming into the economy, you get broader level growth. Like right now, the growth. At least the services growth has touched people from the middle class who, like I said, had good education or had access to good education. The next level of growth can touch a larger population, and that's why manufacturing is important. I don't know whether there is a right way to do it, manufacturing and then services, or services and manufacturing, but this is the path that we are on. And maybe nothing right or wrong about it. But yeah, it seems to be doing okay as of now.
Got it. Cool. I think that paints a lot of perspective on this. Whether we have missed the manufacturing bus or yet to catch it or something like that. Coming to the other very important aspect that I am super interested, and I'm sure like the people who watch it also would be very interested, is about like the latest transformation towards using AI everywhere. And I would love to have your perspective on various aspects of it. Obviously, I think, but first I would probably want to get an understanding of what do you see in terms of typical engineering pyramid of lots of junior engineers and the architects, principals. If you look at social media, that people are saying that, hey, product managers are saying that, hey, we don't need engineers anymore, you can just get code written. Engineers are saying we don't need product managers anymore, you can get PRDs written. And but yeah, I mean, at a very, I think at a on the edge, like at a consumer level, it's not something that is being used at the back end. But people who are writing code every day, people who are using the products which is written to the code, everybody is able to use some flavor of some of these Gen AI, LLM based tools, and suddenly it's like, hey, okay, there's this new way of doing it, and I don't need to do it the other way. But yeah, I mean, in terms of typically like a software engineering process in a large software engineering company, how are you seeing like the Gen AI tools getting adopted, and what sort of shifts in how they work is happening?
I think firstly, I'm typically a skeptic with all these any new technology, because we've seen them all, right? We saw cloud, and we've seen automation, and then suddenly OpenAI, Sam Altman says this is the next big thing, and you have GPT, and like, okay, let's see. But I think what has happened is there's almost been this aha moment for automation and Gen AI after one of these biggest LLM models that they released, the ChatGPT 3.5, right? And the use cases that I think companies like Microsoft were able to provide to even the enterprises. So suddenly, I would say I'm no longer a skeptic, right? And what we fundamentally believe is Gen AI is a truly disruptive technology that maybe at least I have not seen in my lifetime, right? Maybe something else would have happened in the previous generation, but for our generation, maybe it is the most disruptive. And the reason and the areas that it is going to disrupt is, I mean, to put it very simply, any type of content, whatever content you want to generate, can be done by Gen AI at the minimum, right? When I say content, it is written content, two-dimensional art, three-dimensional models, gaming, everything. Talk about any type of content can be generated by them faster, better, more efficiently, right? At the basic level. Now, coming to software code also in my mind is content. It is just content that needs a little more syntax. You need to know exactly how to code, needs logic, but it is content at the end of the day. The second type of content which is maximum used is, and we were discussing, right, the studio use for your ads, etc. So you have agencies that create ads. The content for the ad also is a big thing. The creative part is a big thing. I would say in these both ends of the spectrum, the disruption of Gen AI is very evident in just 1.5 years, right? And although it's still early days. At the same time, I would say that from the ecosystem where we are in, the biggest impact will be seen on the software engineering side, because that is what has carried us for at least 15-20 years now. It is what is allowing companies to come here. We are able to help companies on this side. So software engineering, the way it was done, will definitely dramatically change for sure. And like going back, I said I'll come back to it, right? So when I was an engineer who understood automotive, understood cars, understood the design process of say engines or some of the other components, but I had zero understanding of writing software which helps creating some of those automotive design tools. And I had to learn. It took me, I would say, at least 6 months to get a hang of it, right? Right now, if I were to do that again, it would take me 2 weeks. I could write and be very efficient in 2 weeks. And so what that has done is, one, it has shifted the scale towards people who understand a domain, or who understand a vertical, or who understand a certain type of function.
So for places where code was just a means to get something done, but primarily the job was, let's say, something related to, like, let's say designing a component or something like a medical task, but code was just a means of getting it done. You're saying that Gen AI like augments or
will disrupt it.
disrupts
As long
the
as
need for having a dedicated person to write the code for
Yeah,
that, right?
exactly.
Or for the need for the subject matter expert to learn coding to be able to do that.
Correct.
That effort improves.
That entry barrier is almost gone. It'll go away further, and I'll discuss why. So the first thing that has happened is there were generic software engineering skill set and people who understand the software coding part of it, but the business understanding or function understanding or industry understanding is not really there. So I'll give you an example, right? Like you go to a hospital, and in a hospital there are so many, like even the triaging of the incoming patients. There are companies that write huge software for it, and do we really need those huge software now? Maybe not. There could be a doctor or a radiologist who is looking at x-rays day in and day out. That doctor can make himself or herself more efficient by just writing a simple code and saying that, hey, you be my agent. So GenAI allows not just to write code but create agents, like agent as in a virtual assistant. Like I could be the assistant who is trained to look at x-rays without having a lot of medical understanding. I could be trained to say that these are the things you search for. And because in most radiology about 70 to 80% is fine, nothing is really wrong. In 30% there could be a suspect, and very few cases does something actually happen. But the time spent on this 70% is very large. Now earlier the automation was in terms of trying to figure out how this is done faster, and there were companies creating software for that automation. Right now you don't need those companies, you don't need that much effort. The doctor, if the doctor really wants to do it, can do it themselves by using any of these tools, Copilot, and there are like 30 other different Copilot like tools which help you write code. In fact, we were just studying for so we are creating a big keynote for next month on just GenAI. We found that there are 70 plus tools like Copilot to help software engineers in different places, to, like you said, right, on the main plan, to develop, to test, to finish your code, to test your code, and then to compile your code. All kinds of things it can do. And there's so many different companies, each, and out of those 70, at least 3 are unicorns right now. And they've raised like 40 to 50 billion dollars just within themselves. So the market is getting really disrupted, and hence fundamentally the need for generic software engineering skills will reduce. There is one thing on technology, the other thing is on technology adoption, right? Technology right now is capable of almost nullifying the effect of many of the engineers. But we know from history that humans almost control the adoption, right? They will, right? Yeah. They will ensure that there is enough inertia that all these folks are able to transition into something else. Yeah. The companies will not want to lose their revenue tomorrow. Yeah. They will control the transition in a way where yes, it might benefit a few more than the others, but at the end of the day, humanity per se is not going to like suddenly flip, and you will not have like half the people who are jobless because of this transition, because at the end of the day, humans will control the adoption. The answer is, for as of now, technology exists that you don't need generic software engineers, period. However, the areas where it is going to be the most obvious, high amount of vertical business or horizontal capability knowledge is not needed. And again, like I go back to ad content, right? The person writing your ad content doesn't actually need to know what Scalar does. They will just read about it maybe on your website a little bit, brainstorm, and then get there. They are using the creativity part to do it. But right now there are at least 7 different chatbots that can create that same message by feeding the same data, or not even, you don't need to feed data. You say, hey, let's do it for Scalar. They will look at Scalar's website. By themselves, they will say, okay, these are the 3 things that you can do. Might not be the best, but then again, in an ad agency, you have taken away a significant portion of the generic people's work. Yes, the top creative guy who's creating the line will still be important, but I think that's the same case in most verticals. We will see at least the content generation part get completely disrupted, however complex the content is. MF Hussain might not get disrupted, but some of the others might still get, right?
Makes sense. And then, building up to like probably the most interesting questions that I have for you, which is, whenever one of these waves happen, right, like a major disruption, what I have seen is that typically one thing that plays out is that you have a lot of people who start smaller companies, startups, which can very quickly innovate. And for example, for Gen AI, like, I mean, at the heart of it, it's generating content, but then, what can it generate? Can it generate test cases, or can it generate code and all of that? And some, like you said, 70 different startups have come up which are doing different parts of these components, right? Now, if you look back at the internet wave or the mobile apps wave, I think there were a lot of startups which started, using the internet to doing something connected, but then eventually they got acquired by a more traditional media company, because they see that, okay, whatever, large, $100 billion business that we do, that can benefit from this, connected way of sharing content. And the startup, whatever they had developed, obviously they are probably
media companies,
making a
tech companies.
So no, it's a media tech company. It becomes, because they've got acquired a tech startup, because it makes sense for the startup as well, because they are probably like selling to $10 million of business, but now they can be the digital arm of a $100 billion media company kind of thing, right? Same happened with, I think, apps as well. There were a lot of, if you look at it that way, Android was acquired by Google. It's like the world's biggest operating system today. Like everything from TVs to car dashboards, everything runs on Android, and it was acquired. Like Andy Rubin left Apple and thought that, okay, these smart connected devices people will have on their hands, and it definitely will have a different type of operating system, so let's make it. But like Andy Rubin and 5 of his friends, they can't scale it to obviously 5 billion devices, which now they've been able to. So with AI also, I'm sure this is a theme that will recur here. There will be startups doing this very niche, creative uses of that AI, and I'm sure larger companies also will look towards, buying some of these companies up to augment those parts of their business which they are not able to disrupt themselves, right? From your unique vantage point, I'll probably start with the startup side of the question first, which is, what kind of applications do you think, if people who are really interested in jumping into this field, and I hear it from a lot of my friends who are either who have already or on the verge of like leaving their large company jobs and starting something in Gen AI, and a lot of them are doing it. So what would be your probably perspective on what kind of such problem statements can startups look for? I'll come to the second question, which is what are large companies looking for? That's the second part. But probably for startups, what are some of the spaces which you see have a lot of scope?
Correct. I think that's an interesting question, and we obviously think about this day in and day out. The one way to imagine the answer is to look at the tech stack of, say, even Gen AI, right? So if you look at Gen AI, the stack is at the bottom layer. There is this huge infra, which is nothing but your data centers. And data centers have two main things. One is your chips and the other is your storage, right? And this is where billions and billions of dollars are going in. So a company like Microsoft or Google, who considered themselves as asset light, because software, the only investment you have is mainly people, are now almost becoming like automotive companies, where they have to spend these large capex amount. And we discussed the manufacturing part, right? How much capex you need. So all these companies are spending so much capex on the data center part, or creating. So I think Microsoft just announced that they are going to create a $100 billion AI data center, right? And many more, 60 more in 60 different countries. So that's like huge investment. Now the question is, if you are a startup, do you have any kind of wherewithal to do something in that space? The answer is obviously no, right? Because we looked at that, right? So as a startup, you're almost like how India was 20 years back. All you have is the good brains and maybe a little bit of capital to do it. So infra is not the area where a startup-ish kind of setup can get into. The next layer that they have is are the models that are using these data or processing the data that is coming in, right? And this is what somebody like OpenAI took like 10 years to create. I remember even when we were in engineering, the transforms, right? So if you look at how structural analysis is done, it's mainly you break up let's say this cup into different bits, and you're able to apply load in different areas. And the way you assimilate simulate it is using transforms, so Fourier transforms, etc. So that's almost the same concept in neural networks as well. And now that has gone from there to something that is able to generate content by itself and not just process. So that's the middle layer, right? And this is where the latest GPT-4, they say, is trained on 1.75 billion parameters. So that's why it's called a large language model, right? Now the question is, can a startup do something there? The answer is, in LLM, maybe not, right? Because I mean, firstly you need access to some data center, then access to data, and then there's so much work that has to happen. The answer is maybe not. At the same time, there is one place in this layer where you can operate, and that is new thing that is catching up called small language models. So SLMs, I'm sure you've heard of it, right? Now, what is an SLM? Now, for an LLM to work, it has to operate on that big data center. The data has to go there and it has to come back. There's huge cost of processing it. I think Google says that for every 100, it needs to spend like $5 for every 100 queries or 1,000 queries, it spends $5. So there's a lot of cost associated. If you are trying to solve trying to solve the OpenAI kind of problem.
Small scoped problems, yeah.
Yes.
So there's those on-device models have come up as well.
Exactly.
Yeah.
So now this is a place where maybe large enterprises are very busy doing those big things, right? Yeah. And this is, I would say, this is the sweet spot for anybody smart with access, with understanding of how to, with a business understanding. Again, you have to start from a business problem and then solve it through, say, a small language model. Small language model, the beauty is it doesn't need to even sit on a data center. It could be as small as your app. Like just as you download an app, you could download a small language model on your phone. And the speed with which it operates and gives you the results is just fantastic.
Yeah, a friend of mine has just started up something, and it's like for photographers to auto caption and auto bucketing of the images that they take. Yeah. So like you go to a wedding and take a lot of photos, and so there's like the photo, there's some metadata like the GPS location and everything, but mostly based on the content of the photo, it can like actually auto bucket, like these were photos from Sangeet, these were photos from the cocktail event and all of that. And that's doing on device, like it's all inside the app only, it's embedded. So it's some I think 20 MB model which is able.
Perfect. That's like an excellent example, right? I'll give you a couple of more which are a little more scaled, but started recently. So we recently diligenced a company in the classic GenAI space, right? There are few which are starting up, then there are few which have been there. They were doing automation or AI and now have really adopted GenAI. So this company was able to like think of it this way, right? Like if you're a category manager for Amazon apparel and you are managing men's apparel, on a daily basis you are getting thousands and thousands of SKUs, and each SKU has different colors, it has different parameters, everything is there. Now if you're an Amazon, you have somebody who's trying to manually tag it, or you have some automation to do it. This company was able to say, you just dump all the SKU, whatever images you have, we will auto tag it. We will classify it, tag it, we will put it in the right order, we will do everything. And they said, really, can you do it? And they're doing it. In fact, they have one of these largest companies as their biggest customers. And they've been...
Even if they can auto tag 90%, like the 10% you can do remaining manually, but you still have like...
Correct. In fact, that also you don't need to do. There's a finishing AI apps for that also. So just as you in the normal workflow of like how if you and I were to do it, and if I were to do the basic thing and you're the boss and you know it, you have experience and you do it better for the final ones. Similarly, you have different categories, right? And that's where it makes it interesting. So if you are able to tap into real world problems, use the classic GenAI techniques, maybe create, and the differentiation can be if you have your own small language model. Again, just because we say it is a small language model doesn't make it trivial. It is still very difficult to do because you still need to train it on millions of data.
Specific problem solving rather than a generic problem solving.
Correct. So for example, let's say my doctor friends who was looking at one of these problems, right? Like he's a neurosurgeon, and in neurosurgery, it's almost like the bleeding edge of healthcare or medicine, right? Because there's so many new papers that come for every type of different surgery all the time. In fact, it's true for most in most surgeries, but in neuroscience it's a little more. At the same time, there's almost humanly impossible to read those 100 papers that are coming every day, and also which of them are in your context. The ability of that person, although he was actually sitting with another software guy who knew this, but the fact is that he was able to just very quickly say what type of surgeries I'm looking at, where I'm looking at, and I need to know the impact, and basis the impact and ease of operation, because some of them suggest like very specialized tools. You just give me the basics of ones that I can read every day. It's just almost think of it as a personalized digest that is made for you. These are the kind of things which ideally you would have paid a lot of money for a subscription, and then on that subscription you would pay for a service to somebody curate and digest for you, right? Like a premium service. I think those kind of things, if you can create, like for example, sit with this neurosurgeon, create this out, and it's very easy to scale. Like go to different hospitals, and from neurosurgery go to cardiology and so on and so forth. So I think the opportunity is, I would say, immense to solve problems that typical software has not been able to solve yet, or in domains where it is still very expensive to. I'm sure if you tell Microsoft to solve this problem, they will solve it, right? They have a huge hammer. They'll solve. It'll crush any fly. But these are the cases where large enterprises are still will take time to reach. They've big huge problems, right? Like how do I really scale? How do I make GenAI accessible to all the enterprises? That's what Microsoft is thinking. How do I make it accessible to you and me sitting and using Microsoft Word? And that's why their spending is on infra, more on LLM. And then there is a third layer. The third layer also we kind of discussed, right? This is your actual apps which use GenAI, or agents that use GenAI. So I think this is how I would imagine, thinking through a startup idea within leveraging GenAI. I mean, if you're really, really into it, then you can also look at the content disruption space, right? Like one of the things that has been done and dusted is your document scanning and categorization, like FP&A. They do it all the time. However, whatever automation tools are there in the market are still very restrictive. With GenAI, they can become adaptive. They can do things more flexibly. So those are incremental innovations that you can look at. Same thing with ad creation or creation of certain content. There's always that little bit which has been left from the classic automation, which can be done with GenAI. So I think there are multiple places, depending on how much mental bandwidth and money bandwidth you have, you can explore. Yeah.
And the final question about the flip side of this is, how are because you're in this space and you have probably been advising larger companies on this, what are they looking for, like when they're looking at acquiring such disruptive companies? What parts of their problem space are they looking to augment? What are they looking for in the market?
Yeah, I think I think what they're looking is not very, very different from the standard way of investing. At the same time, whenever there is a new technology, there is always this gap of understanding of technology between the person who's doing it and the investor. It's always there, and it almost never goes away. Maybe after 3 years, people in the investing community will know exactly what it takes to create a small language model, but right now it is only paper and bookwork. So one of the things that we typically encourage companies who are in newer technology spaces is to try and abstract the impact. Like for example, like the company, like I said, that we were diligencing, one of the great things that they were able to do is do nothing but look at their own customer data. They requested for it and they asked the customer, hey, before you implemented my solution, just give me 1 year data on how many people you had, how much time you took, how many SKUs you were able to place, multiple parameters. Right. And do that exercise to once it is implemented, or in the pilot what happens, right? I think everywhere where you can show any clear business impact, that is important. Second, many of the, and again it might, the other, I would say, a business related problem with new technologies, almost no new technology implementation is clean or completely off the shelf, right? Like you can't just go and put it in and it'll solve your problem. The same thing with Gen AI related one.
At a researchy level right
correct.
now. Yeah.
Somebody has to make those connections, has to do something, has to tweak it, or maybe 5 people have to sit in that company and ensure that those SQ tagging is being done properly. So there is a risk that while you are trying to perfect the product, your first 2-3 customers are actually looking like services companies, right? They are not necessarily paying you for the license for the product, because if you're a product company, you get paid on license. You get paid, but you're paying for.
So you are doing like solutions for a while before it becomes a product. Yeah.
So I think that is where the companies that are investing are very careful. If your product or your so-called product is close to a solution, I would suggest that they wait for a while, right? Because whoever is investing will look at it and say that there is work to be done. Whenever there is work to be done, that means you need to pay less, and that there is risk, right? There's risk, operation risk is there. Fourth is, there are some VCs that think of it as an opportunity, but then they will look at, hey, is the person doing it really good? But the problem with new technology is the understanding is poor, right? So they're looking for some proven use case. So if you're in solution stage, I would say wait for 6 more months unless you're really pressed for funds. Once you have decent scale, you have one customer which is impactful, that's it. Then you can get the valuations or investment that you really desire.
Nice. No, this is really enlightening, I would say, for me as well, to just see, like, I think both sides of the coin, and I'm sure especially like I was saying, I know a lot of people who are starting to try out their hands in this space. I think these answers would be super helpful for them to get this context. It was really nice, all of the answers. I think especially the insights on how Gen AI is impacting the market. I think these were a really great conversation, and once again, thanks for very patiently answering all of the questions around your journey, for how you went into from engineering to consulting to like the current engineering space in India as well. Thank you once again for all the answers.
Absolutely, Arnav. As you can see, we are a very passionate bunch of folks in Zinnov, especially on engineering and technology. So happy to answer your questions, and thank you for the opportunity. Happy to be here.
Thank you.
And your team as well has been wonderful. Thank you so much.
Thank you, Sundar.